Hello and welcome to this session on statistics. In this session, we are going to have introduction to hypothesis testing. Now, what is a hypothesis? So, hypothesis is nothing but a claim or a proposed explanation given by someone. So, it's an idea or a claim. So, hypothesis testing is where a claim that can be tested. We can call it as hypothesis testing. So hypothesis test evaluates two or more mutually exclusive statements about a population to determine which statement is best supported by sample data. Now here, suppose we are doing a test with respect to COVID-19 vaccine. Suppose there is a company which came up with a vaccine for COVID-19. Now company came up with a vaccine name is suppose X. Now here to check like if that vaccine is going to work out or not, we have to pick a sample and we have to check that with respect to sample. Now here the claim made by the company is like this is the vaccine which is going to work for the COVID-19. But now to see if it is really going to work or not, so we have to test that hypothesis. We have to test that claim that it is going to work. So now in this scenario, we will be picking some sample data and we'll be working on top of that. And we'll see how that sample is matching to the population data. So like we'll see, okay, is this sample getting affected enough or not? By taking those medicines, like those medicines are affecting the sample or not. So in hypothesis testing, we evaluate two or more mutually exclusive statements that is about a population to determine which statement is best supported by the sample data. So now here we have two things within this kind of hypothesis testing. We have two things. One is null hypothesis. The other one is alternate hypothesis. So null hypothesis is the currently accepted value for a parameter. So it is the currently accepted value. So it is an assertion that we hold as true unless we have sufficient statistical evidence to conclude otherwise. So null hypothesis is denoted with H naught, that is H0. This is the symbol for null hypothesis. So it's the currently accepted value for a parameter. Suppose to take that same example, suppose we have to figure out if a vaccine is going to work out or not with respect to COVID-19. Now the claim which is made by the company saying that this vaccine is going to work out. So that is nothing but the null hypothesis. And alternate hypothesis is the opposite of null hypothesis. So mathematically it is the opposite of null. So alternate hypothesis is negation of null hypothesis and is denoted by HA or H1. So here, like we denote it as HA or H1, it is also called as research hypothesis. In some of the books, you will find it as named as research hypothesis. So alternate hypothesis involves the claim to be tested. So now here, suppose as a statistician, we cannot like suppose we directly will not be believing what a company is saying. Suppose a vaccine company is there and vaccine company is saying that this vaccine is going to work out. So we have to see if it is really going to work out or not. So for that we will do research hypothesis. We will try to check if it is going to work out or not. So that will be alternate hypothesis. Now to take some more example and to understand this, now here to take the example of suppose we'll take the example of law of gravity. So now we know that there are two people like who are there who formulated the law. So first guy who formulated the law was Newton. Okay, so Newton formulated the law of gravity. So now when Newton came up with the law of gravity, so how did Newton came up with this law? So the evidence what Newton used for the law was nothing but an apple. So an apple falling from a tree, Newton thought, okay, like this is something where like some law might be associated, and that's where he came up with the law of gravity. Then later on, Einstein came up again with the same again with the law of gravity. Like Einstein also proposed a law. So Newton already proposed the law of gravity, and the evidence what Newton had was nothing but apple. But when Einstein came in, Einstein was more towards space-time. So like he was known for space-time. So Einstein said that whatever Newton has proposed, whatever law Newton has proposed is not the right way to compute gravity. So basically gravity is more complex. It's more related to space-time. So that's why like Einstein formulated a law which is a little bit more accurate as compared to the Newton's law. Newton's law was more like a simpler version, and Einstein again worked on that and created a law on top of that. So saying okay, like law of gravity is more related to space-time rather than apple. So here Newton, when Newton proposed the law, so this law was being accepted and everywhere. So that was the null hypothesis. So here the null hypothesis will be the Newton. So when Einstein came in, for Einstein, the null hypothesis was nothing but Newton's law of gravity. So when Einstein started working on that law, so that is nothing but alternate hypothesis. So alternate hypothesis is like exactly opposite of null. It will always be opposite of the null hypothesis. So now here, this is how we can formulate null hypothesis and alternate hypothesis. So null hypothesis is a currently accepted value for a parameter, and alternate hypothesis is the hypothesis or claim that has to be tested. It's like testing the hypothesis. So it involves the claim to be tested. So for Einstein, like null hypothesis was the Newton's law of gravitation, and he was testing like if it is true or not. So that's where that was the alternate hypothesis, which is also called as research hypothesis. Now, null hypothesis and research hypothesis are exactly opposite of one another. So now here, suppose we uh, suppose somebody is tossing a fair coin. Okay, suppose we will take an example, one more example here, tossing of a fair coin. So there is a coin which has got head and tail. One side is head, and the other side of the coin is tail. So now here, what is the probability of getting a head or tail? Suppose somebody asks you what is the probability of getting a head or tail. So we know the probability, that is the null hypothesis here, like the currently accepted value here, that is the probability for this is nothing but it is 0.5. So probability is 0.5 here. So that is 50% chance that it might be a head or it might be a tail. So suppose somebody is tossing a coin, there is a 50% chance that it like that guy might get a head or a tail. 50% is there. So now here alternate hypothesis will be exactly opposite to null. So if null says p is equal to 0.5, alternate will be the parameter is not equal to 0.5. So it will be exactly opposite. Now here alternate hypothesis is nothing but suppose we are tossing the coin. Suppose we toss the coin for 10 times. Out of that, like 7 times we are getting head. So what is the rate of getting head? What is the probability of getting head? So it's like 7 divided by 10. So 70% chance. So it changed. The hypothesis changed. So now here null hypothesis is nothing but the currently accepted value for a parameter. Alternate hypothesis involves the claim to be tested. So here we are basically testing the claim. So alternate hypothesis will always be opposite to the null hypothesis. And one more important thing within this hypothesis testing is hypothesis testing is done with respect to one kind of value, like one kind of parameter. So here as we are testing a probability parameter, it can be an average, like a mean parameter. So like that, like hypothesis testing is always done with respect to a parameter. So here null hypothesis says the parameter is equal to something, so alternate will be exactly opposite to that. Suppose here the parameter is mean. Suppose here we have a parameter mu. Suppose the mean is, suppose null hypothesis says that mean is greater than 256. Suppose there is some hypothesis testing, and we are saying okay mean is greater than 256. So here alternate hypothesis will be mean is less than equal to 256. So it will be exactly opposite to null. Alternate will be exactly opposite to null hypothesis. So now here, like whenever we are doing a hypothesis testing, so what kind of outcomes will be there? So one is either we reject the null, or the other one is do not reject the null hypothesis. Now when somebody is doing a hypothesis testing, now suppose somebody tells us, that like when we are tossing a coin, the probability is 50-50% of getting head, 50% of getting head, and 50% for getting tail. Now here, suppose we want to see if that is the actual case or not. So now for that we will do an hypothesis testing, and suppose we found that probability is not 50%, probability is more than that or less than that, then we will reject the null. We will say no, null is not true. So we will reject the null. Otherwise we will not reject the null. Now suppose the probability is matching, suppose it is 50%, we will not be able to reject the null. So we will go with the null hypothesis. So there might be two possible outcomes in any hypothesis testing. One is reject the null hypothesis, or the other one is do not reject the null hypothesis. So now when we do a hypothesis testing, there might be two kind of error which we can get into. So these are two types of error which are there in hypothesis testing. One is called as type 1 error and the other one is type 2 error. Now when we are doing a test and we are deciding on should we reject or not. So suppose we are doing a test and we are rejecting the null. Suppose null is true and we are rejecting the null hypothesis, then it is called as type 1 error. So we did a hypothesis testing where null hypothesis is true, but after doing the test we rejected the null hypothesis. So it is called as type 1 error, which is also called as alpha error, or it's called as false positive. So here this is type 1 error or alpha. This is also called as false positive. Suppose we are doing a test and null hypothesis is false. Suppose null hypothesis is false, but we are accepting the null hypothesis. We are accepting the null. Null is given as false, but within our test we are accepting the null hypothesis. Then it is called as type 2 error, which is also called as beta error, and this is called as false negative. This type of error is also called as false negative. So there are two types of error. So in one case, suppose hypothesis in reality hypothesis is false, like null hypothesis is false, and like when we do the test also we are rejecting the null hypothesis, so we are also proving it to be false. So that means that is a true scenario, so that is a correct rejection scenario. The other one is suppose in reality null hypothesis is true, and when we do the test also we are accepting the null hypothesis, we are also proving it to be true, then that's also a correct scenario. So that means there is no error. So these two scenarios are correct scenario. When the scenario is incorrect, that means there is some error which occurred. So there are two types of error which can occur. One is in reality if null hypothesis is true, but within our test we are rejecting the null, then it is type 1 error, which is called as false positive. And suppose in reality null hypothesis is false, but we are accepting the null hypothesis within the test after doing the test, then it is type 2 error, which is nothing but false negative. So these are two types of error within hypothesis testing. Now we'll understand a little bit more into hypothesis testing. That is, how do we do this hypothesis testing? So we just understood, okay, what is hypothesis testing, and we just understood what is null hypothesis, that is the currently accepted value for a parameter. So that's the currently accepted claim, and alternate is the opposite of null, mathematically opposite of null. So there we test the null hypothesis. So we test the claim. So to test that, we have something called as test statistics. To test this hypothesis, we have some measure which is called as test statistic. So to check the null hypothesis, we calculate a figure known as test statistic, which is based on data from our samples. Now to do a hypothesis testing, we might take a sample of data and we will work on top of that by using something called as test statistic. And then we will decide, okay, should we reject the null or should we not reject the null hypothesis. So there are different types of problems which are there, which require different type of test statistics. So there are multiple type of test statistics, like z-test is there, which we have already seen, that is z-score, and there is this one, that is t-test. There is f-test. There are multiple types of like test statistics which are there to check the hypothesis. Now, state statistics gives us values for comparison of to our data that have all been put into statistical table. So now here within test statistics, we'll get some values for comparison to our data, which has been put to some statistical table. So now each of these tests has got some of its table. Like z test has a z distribution table, t test has a t table. Like that, all these test statistics has got its own table. So all we need to do is to calculate our value. So we will use the test measure, test parameter, and we will calculate the value, and we will be comparing it with the value in the table to get our answer. So going ahead, we'll be looking into, okay, what is the process and how do we do this test statistic. So now within this test statistic, to take some examples and to understand a little bit more, suppose taking a generic example, suppose it is claimed by a chocolate company that all chocolate bars named X weighs 10 grams. Now here suppose there is a company which is manufacturing chocolate bars, and that company is claiming that each of the chocolate weighs 10 grams. Now here few people have claimed that all the bars are not actually 10 grams. So few people have claimed that it is not 10 grams. So now here first thing is to understand what is null hypothesis here. So null hypothesis is the claim. So here claim is made that each of the chocolate bars weigh like 10 grams. So we'll say suppose the average, that is the mu, that is the population average or mean, is 10 grams. So it is around 10 grams. So now here the alternate hypothesis will be mu not equal to 10 grams. Alternate will be mu not equal to 10 grams. Now here we will first, like, what are the steps to carry out the test. So first we'll be taking a sample of some chocolate. So suppose I will say 50 samples or 100 chocolate bars, 100 samples. So we cannot take all the chocolates, so there will be a millions of chocolates. So we'll take few chocolates out of that. So that's what, like, usually when you get into something, okay, like suppose you want to test it manually, you will go and pick some chocolates. So suppose we pick 100 chocolate bars. Now here we will calculate the average. First we will get the average of all the bars. So here average of all the bars, that is mu equal to 10 grams. So that is our null hypothesis. So it says the average weight of all the chocolate is around 10 grams. Now alternate hypothesis will be that it is not equal to 10 grams. The average is not equal to 10 grams. So now for that we'll be calculating some test statistics. We'll do test statistics. Suppose we did a test statistic and we got a test statistic value as suppose we got an average value here saying it is near to, after doing test statistic we got an average value somewhere near to suppose 9.8 grams. Okay, suppose this is the first we got. So we took some 100 chocolate bars and we did a test, and after doing test statistic we got that the new mu, that is the average, is actually 9.8 grams. So in this case it is not 10 grams, but it is near to 10 grams. Now again suppose we took a different sample of 100 chocolate bars. Now again we did the test and we got a mu of like I will say here 8.9. Okay, suppose we got a average of 8.9 grams here, which is also very much nearer to 10 grams, but it is actually not 10 grams. Now again suppose we took some samples, so like that we took multiple samples and we did the test. So again we got a mu here of around suppose 7.2 grams. So now we got first time 9.8, then we got 8.9, in the third case we got 7.2. So now in the third case, like, we can directly reject the null hypothesis because like we are more confident enough, because we can say okay 7.2 grams is far enough, like it's not matching to 10 grams. So we cannot say okay all the chocolates are going to weigh 10 grams. But when we are getting 9.8 grams like after doing the test, That means we cannot simply reject the null because it is very nearer to the null hypothesis. In some cases it's fine, but in our case we cannot simply say okay, we'll reject the null because 9.8 gram is very much nearer to 10 gram as an average. So here basically what is the best like average to take? Okay, what is the right value to take? So that also we need to figure out within test statistic. So for that we have two things, that is one is called as level of significance, the other one is called as level of confidence. Now here to do any test statistic we have these two major like measurements. Now here one is level of significance. So now this level of significance means the percentage risk to reject a null hypothesis. So what is that percentage at which I can reject the null hypothesis when it is true? And this is denoted by alpha. So this level of significance is denoted by alpha. So statistically significant is where we draw the line to make a decision. Now to make a decision, should we reject the null hypothesis or not? If the null hypothesis is true or not. So we have to take a significance level. We have to set our own significance level. So here generally like the significance level which usually statisticians take are like 1%, 5% or 10%. But like it can change, it can vary with respect to the problem scenario. So now here we have to first figure out what is the alpha, that is level of significance. So if I say 5% significance, okay, like suppose like my significance level is 5%. So here to compare this we have something called as level of confidence. Now level of confidence tells us how sure or confident our result is. It is denoted by C. So the 95% confidence means you can be 95% certain. 99% confidence means you can be 99% certain, and so on. So confidence level is written in decimal values. That is like 95% means 0.95, and it is given like this. That is C equal to 1 minus alpha. Here alpha is nothing but significance level. So first we have to set our significance level. Suppose we are taking the significance level of 5%. Suppose we take significance level of 5%. So now we know that confidence is nothing but C equal to 1 minus alpha. So that will be 1 minus 0.05. This is 5%. So it is nothing but giving us 95%. So that means if we are 95% certain on our result on the investigation what we did, if we are 95% certain, then we will reject the null hypothesis. So how sure we are to reject the null hypothesis, that is how sure we are or how confident we are on our result, on our test statistic, that is level of confidence. So if confidence is high, then we can say okay, like we can reject the null. So in this case, like as we took the example here, we can see the confidence is more high towards the third one, that is the third test when we did. So it is around 7.2 gram we are getting, so which is very far from 10 grams. So we have more confidence here, so we can reject the null. So that's where this is decided by level of significance. Based on the type of problem we are working on, we have to set the significance level. So for like medical scenarios, like critical scenarios, level of significance can be taken as 1%, or it can be taken as 5%, it can be taken as 10%, it can be taken as 8%. So if level of significance is taken as 5%, then level of confidence is going to be 95. If level of significance is taken as 1%, then level of confidence is going to be 99%, like this. So it is given by 1 minus alpha. So significance level is something which we have to set. Whenever we are doing any hypothesis testing, based on the type of testing we are doing, we have to set the alpha value. Sometimes alpha value is given within the test, it's given by a specialist, or sometime like we have to set by understanding the problem statement. We have to set this alpha value, that is the level of significance. So once we set the level of significance, it will also denote what is the confidence level. So confidence level is given as 1 minus alpha. So confidence level means like how certain or like how sure or confident our result is. So now here when we do any test statistic, So first we understood, okay, there will be some type of test measure like using which we will do a test statistic, and to figure out should we reject or do not reject a null hypothesis, we have significance level. We have to set the significance level which will define the confidence value, and based on that we will reject or do not reject the null. So now here within this we have two types of tests. There can be like actually three types of tests which can come up. Like any test statistic we take, there are multiple types. One is called as two-tailed test. The other one is left tail test, that is one-sided test, and right tail test, that is also one-sided test. So we can have two-sided test or two-tailed test or one-sided test or left tail or right tail test. Now here what is two-tail test? Now to take an example, so here there is one example. So first what we do is, suppose we will distribute our data with respect to probability distribution. Now here like significance level is the probability of rejecting the null hypothesis given that it is true. So now suppose we have taken the significance level as 5%. So that is 5% is the significance level. That means confidence value will be 95% in this case. Now here suppose we distribute the data within this one, that is probability distribution within normal distribution. So now here we have something called as acceptance region and the other one is rejection region. So when do we reject the null hypothesis? That is our rejection region. And when do we accept the null hypothesis? That is our acceptance region. So now here acceptance region is the confidence value. Like if we have higher confidence value, like this is your acceptance region, like higher, like lower than this one. That is 1 minus alpha. 1 minus alpha is nothing but confidence value, 95%. Now anything falling within this white area, this will be the acceptance region. Anything falling within this shaded area is the rejection region. Now here suppose we take alpha as 0.05, which is nothing but 5%. So now when we do two-tailed test, this is also called as two-sided test. So when we do two-tailed test or two-sided test, we have to divide this value by 2 so that we can take both the sides, and here it will be 0.025 in either of the side, that is 25% in each of the side. So alpha will be this one, that is our alpha. So this is our alpha, this value is alpha. So alpha is 0.025. So anything falling below 0.025 will be the rejection region. Anything falling below that, so that is nothing but the rejection area, and anything falling above that, then that is the acceptance area. So if the confidence value is higher than 95%, then like for our result, suppose we are doing a test and we got some result and the confidence value is higher than 95%, then we'll be rejecting that particular like null hypothesis, because we are more confident with our alternate hypothesis. Otherwise, if the confidence value is lower than 95%, then we have to go with whatever is already there, that is the null hypothesis. We have to accept the null hypothesis. So this is how like two-tailed or two-sided tests are done. Now here we can also do one-sided test, that is like suppose if we take the example of left-tailed test at 5% significance level. So we can take 5% of the left hand side, so that is our alpha is 0.05 here. Anything falling below that will be the rejection region, and anything falling above that will be the acceptance region. Similarly, if we take right tail test, this is also one-sided test in which we will take the right side of the probability distribution. So suppose we take 5% significance level to the right, so then here rejection region will fall towards the right. Anything below that rejection region will fall towards the left. So this is right tail test. Now we will do some tests and we'll try to understand this with respect to some real-time scenarios. Now to do the test, first we need to understand something called as p-value. So what is the p-value here? So p-value is the smallest level of significance at which we can reject the null hypothesis given the observed sample statistic. Now once we do the test statistic, we'll use some z test or we'll do some t test, any kind of test we do. So after that, we'll be having something called as, we'll be getting something called as p value. So p value is nothing but the smallest level of significance. So this tells you what is the smallest level of significance at which we can reject the null hypothesis. Now here, like if you look at this particular image, so this is a right-tailed test. So now within this, suppose we have this alpha value. So this is our alpha value, observed data point, which is suppose 0.05. So now here p value is nothing but anything falling within the shaded area. That is the p value, which will define what is the probability value. So is the probability of an observed or more extreme value, that is the more extreme result, assuming that the null hypothesis is true. So it is the probability of an observed result assuming that the null hypothesis is true. So once we get that, like if any value is falling below the alpha value, so those values are nothing but like p value. So whatever p value is there, if those p values are less than alpha, then we reject the null. So that means it is not going to support the null. Null is falling somewhere in the middle. So this part is nothing but the part where we can accept. But if our p value is falling below that, below the alpha value, alpha is nothing but this is the significance level. So if it is falling below the significance level, then we will reject the null. If it is falling here, if the p value is greater than alpha, okay, then we will not reject the null hypothesis. If it is greater than alpha, that means it is falling towards the acceptance region. So now that is how it is given, that is p value, if it is less than alpha, then reject null hypothesis. If p value greater than equals to alpha, do not reject null hypothesis. So this is how we actually interpret the p values. So we'll take an example here to understand this specific scenario. So here basically, suppose imagine you are consulting an university and you want to carry out an analysis on how students are performing on an average. Now here you just have to analyze how students are performing on an average. So now here suppose university dean says that students have a GPA of 80%. So students are getting a GPA of 80%. So here population mean grade, like the grade of the student is nothing but 80%. That is what is claimed by the university. So suppose university dean is saying that the average grade, that is the GPA, is somewhere around 80%. So I'll say here H naught, that is the null hypothesis. We can denote it as mu 0, which is nothing but which is equal to 80%. So this is what is the hypothesized value. So this is our hypothesized value here, which is claimed by the university. Now here, as a statistician, like we have to figure out, okay, if this is true or not. So we have to analyze this and find out if like actually it is 80% or not. So then we will take alternate hypothesis value here, that is mu 0 is not equal to 80. So it says it is equal to 80. In the university dean says it is equal to 80%. So we will take the alternate hypothesis not equal to 80%. Now here suppose we distribute all the grades of students. Suppose we took some sample of data and we distribute the grades within some normal distribution. Suppose this is our distribution, this is a normal distribution, and within this we distribute the grades of each of the students. Now here this is where the mu 0 is falling. So this is the average that is the average grade of students. Now suppose we perform some type of test here. So we'll do some test here, that is test statistic. So we did some test statistic here. So now here after we did the test statistic, we figured out, suppose if sample mean, suppose we got a mean that is from the sample data, if that sample mean is close enough to the hypothesized mean. So this particular mean is nothing but hypothesized mean. So hypothesized mean is the population mean, like which is the currently given mean. So that is hypothesized mean. So suppose we took the sample data and we did the test, and we found that the mean is close enough to the hypothesized mean, then then our test statistic value also will be very nearer to this mu 0. It will be very nearer to mu 0. So in this case, we cannot reject the null. So we will go with null hypothesis. If the value is falling far enough, now here suppose we take some decision boundary here, that is nothing but we will take some significance level here, saying this is a two-sided test. Suppose our significance level is 0.5 50%, so we'll take it as 0.025. If it is a two-tailed, it will be 0.025 both the side. So now here what will happen? So now we have taken a two-tailed test here. Now here in this scenario, like if our value is falling outside this alpha, so then we will be rejecting the null. Otherwise, we'll be going with the null hypothesis. So this is the acceptance region, and this shaded area is nothing but the rejection region. So shaded area is the rejection region here. So anything falling around the rejection region will be we'll be rejecting the null hypothesis. Otherwise, if our average is falling near to this acceptance region, then we will accept the null hypothesis. So this is how hypothesis testings are done. Now this is a two-tailed, that is two-sided t-test. Now when do we do one-sided t-test? To take one more example, when we can do one-sided t-test. Now here suppose the same example we will take. Suppose university dean says the mean grade is lower than 80%. Suppose university dean is claiming that the GPA of students is lower than 80%. Sorry, is lower than 80%. So here basically university dean is saying null hypothesis, that is the currently accepted value which is given by university dean, is lower than equal to 80%. So now alternate hypothesis in this case will be, here I will take mu 0 only, alternate hypothesis will be greater than 80%. So we will check if the null, to test the null hypothesis, we have to take this alternate hypothesis. So in this situation, we have to go with one-sided test. That is, suppose this is our distribution of the grade. So this is distribution of grades. Now within this, suppose we take the significance level of 0.05, and here we have the mu value, that is nothing but 80%. So here if the values if the values are falling more, so here we have to check if it is more. So if it is less than 80%, then we have to accept the null hypothesis. Otherwise, if it is greater than 80%, we have to reject the null. So now here rejection region is this part. So this is where like one-sided test we can do. So this is where we will do one-sided test. So when we have to find out, okay, something is greater or lower in those kind of scenario, or else we can do a two-sided or two-tailed test. So now we just understood two-tailed test as well as left tail, right tail, that is one-sided test, and p-value. So p-value is nothing but the smallest level of significance at which we can reject the null hypothesis. Now how to get the p-value? Once we do any kind of test by using test statistic, we will be doing the test on top of hypothesis, and once we do the test, we will get some test statistic value, and then that value we can compare in the table. So there is statistic table for each of the tests, there is table. So we have to compare it on the table to get the p-value, and based on the p-value we will decide should we reject or do not reject the null. If p-value is less than alpha, that is significance level, we will reject the null. If p-value is greater than equal to alpha, then we will not reject the null. So now this is the procedure for hypothesis testing. First, state the null hypothesis and alternate hypothesis. So whatever problem statement we have been given, First, we have to find out what is the null hypothesis and what is the alternate within that. Then we have to set a significance level. So state a significance level that it can be 1%, 5%, 10%, 8%, 9%, depends on the type of problem statement we are working. So based on that, using some domain specific knowledge, we have to set the significance level. Once significance level is done, like set, after that we have to do test statistic, like we have to test the statistic. That is, we can do z test, t test, f test based on the type of sample. Then calculate the value of test statistic. We have to calculate what is the value we are getting out of the test statistic. Then we have to calculate the p-value at that given significance level from the table. We have to use the table and find out the p-value with respect to the test statistic value, and then we have to compare the p-value with the calculated value, and if the p-value is greater than calculated value, that is nothing but the significance value, then we will accept the null hypothesis. If p-value is less than the calculated value, that is less than the significance level, then we will reject the null hypothesis. So p-value less than significance level means it is not accepting, it is not falling near to the actual data, it is not falling near to the observed data. So that's why like we'll be rejecting that. So because our confidence value is much higher towards our result. Now here we'll just see one specific test, and we'll take some example and we'll do this test. So we'll see z test. So this is one of the basic hypothesis testing or test statistic measure which is there in hypothesis testing, that is z test. So a z test is any statistical test for which the distribution of the test statistic under the null hypothesis can be approximated by a normal distribution. So that is like any test data or any data like which is falling under the null hypothesis which can be approximated by a normal distribution, then we can implement the z test on that. Z test tests the mean of a distribution. So it will be basically testing the mean of the distribution. So a z statistic or z score is a number representing the result from the z test. So when we do a z test, we will get some value or a number which is also called a z statistic or z score. So now this is the formula which is given for the z test. So that is z equals x bar. So this x bar is nothing but this is the sample mean, and this mu is nothing but population mean, or you can call it as hypothesized mean. And this one is standard deviation divided by root of n. This is also called as standard error. This is the formula given for z test. Now using this formula we can test a statistic value. Now here what we will do is like we'll take one example and we'll see this practice example. Now here it says blood glucose levels for obese patient have a mean of 100 with a standard deviation of 15. So now it just says, okay, this is like obese patient. So blood glucose level of obese patient have mean of 100 and standard deviation of 15. So a researcher thinks that a diet high in raw corn starch will have a positive effect on blood glucose level. So a sample of 36 patients who have tried the raw corn starch diet have a mean glucose level of 108. Test the hypothesis that the raw corn starch had an effect or not. So now here a researcher is claiming that if you give a diet which is high in raw corn starch, it is going to have a positive effect on the blood glucose level of the obese patient. So that's why like researcher took sample of 36 patients and like gave them raw corn starch diet and got a mean glucose level of 108. So we have to test that the raw corn starch had an effect or not. So now first thing what to do here. So first we will be picking all the parameters. So now here it says blood glucose level for obese patient. Okay, now before understanding this, first we will see what is the null hypothesis here. So what is the claim which is made by the researcher? So here it says the researcher thinks that a diet high in raw corn starch will have a positive effect on blood glucose level. So this is the claim which is made by the researcher. So this is the null hypothesis. that a diet high in raw corn starch will have a positive effect on blood glucose level. So null hypothesis is diet high in raw corn starch will have a positive effect on blood glucose level. And alternate hypothesis will be exactly opposite. That will be diet high in raw corn starch will not have a positive effect. Okay, so it will not have a positive effect. So that will be the alternate hypothesis. So now here, first what we have to do is we'll just pick up the like we will do the z test on top of this. So z test is given by the formula, that is x bar minus mu population mean divided by standard deviation. So I'll take here standard deviation divided by root of n. So this is what is the formula, like which is there. So here I will take it as S, that is standard deviation. So here within this, what we have to do is first we have to put all the values and test this. So for testing this, like first we need all these values. So what all values are there within the problem, like we'll take those. So first it says the blood glucose level for obese patient have a mean of 100 with a standard deviation of 15. Now for all the obese patient, the blood glucose level is given as 100 mean. So mu is 100 here. And the other thing is sample mean, like we have to see the sample mean. So sample mean is 108. That is a sample of 36 patients. So sample size is 36, which has a mean of 108. And standard deviation is nothing but 15. So that is population standard deviation, which is nothing but 15. So standard deviation here, we can write it like this, or we can write it as S equal to 15. So we can give it as sigma or S. So now these all values we have. So now once we put that within this z test value, so first is x bar, that is the sample mean, that is 108, minus mu is 100, divided by standard deviation 15, divided by root of n is 36. So once we compute this, like we will be getting somewhere around 3.20. This is what value you will be getting, like 3.20. Now the z value or the z score or test statistic value, this value is also called as test statistic value, which we got is 3.20. Now we can look into the probability. So to find out the p value, we have to look into the z table. So if you search in internet z table, you will get the z tables. So when we look at the z table, we will find out the p value from that. So p value associated with this 3.20 will be you'll be getting this one, that is 0.9993. This is the p value. Now here like we got the p value and we got the z value, that is z test value. Now we know if p value is less than alpha, suppose we tell here alpha is nothing but 0.05, that is what is the basic which we can take. So significance level is nothing but 0.05, that means 5% is the significance level, so confidence is 95. So if p value is less than alpha, then we will reject null, and if p value greater than equal to alpha, then do not reject the null. So here within our case, we see p value is greater than equal to alpha, that is p value 0.9993 is greater than 0.05. So here we cannot reject the null hypothesis. So that means we have to go with null hypothesis. That means a diet high in raw corn starch will have a positive effect on blood glucose level of obese patient. So whatever researcher has claimed is true. the claim is true. So we will not reject the null hypothesis. So do not reject null. So null is true here. That's what we got. So this is how we can do hypothesis testing. Okay, so now just to summarize again, so what all we did. So first we looked into what is hypothesis testing. Then we understood what is null hypothesis and what is alternate hypothesis. So null is the currently accepted value for a parameter. Alternate hypothesis involves the claim to be tested. It is the opposite of null. And then we saw what all outcomes we can have after doing a hypothesis testing, that is either reject the null or do not reject the null. So here we also understood something called as error within hypothesis testing. There is type 1 error and type 2 error. And then we understood how to do hypothesis testing, that is by using something called as test statistic. So these test statistics are of various types like z-test, t-test, f-test. So depending on the type of data and the type of problem, we'll be selecting a test. And then here when we do any statistical test, we will be getting a value. Suppose we did a z-test, we get a z value. Then we have to compare that value with respect to the statistical table which is there for z-test, and based on that we will compare it with the significance value. So we also understood what is the level of significance and what is the level of confidence. Then we saw what is two-tailed test and one-tailed test, that is left-tailed or right-tailed test. Then we saw what is a p-value, and we understood that if p-value is less than alpha, then reject null hypothesis. If p-value greater than equal to alpha, do not reject the null hypothesis. Then we also understood how p-value can be interpreted. So it is the probability which falls here, that is the probability of an observed result, assuming that null is true. And then we took some examples, and then we understood the procedure for hypothesis testing. That is, first state the null and alternate hypothesis, then set a significance level, decide the test statistic, then calculate the value of the test statistic, then get the p-value from the table, then compare p-value with calculated value. That calculated value is nothing but significance value. If p-value is greater than that calculated value, then accept null. If it is less, then reject null. So then we saw z-test. So z-test is any statistical test for which the distribution of test follows a null hypothesis, follows a normal distribution under null hypothesis. So here basically to check the mean of the distribution, we use this test. Now the formula for z-test is x bar minus mu divided by standard deviation divided by root of n. So where x bar is sample mean, then we compare it with the hypothesized mean, and we check it with the standard error. Now we also took an example to understand how hypothesis testing can be implemented with respect to real-time problems. So this is all about introduction to hypothesis testing. Thank you for attending.